All right, this is an optimization problem from section 4.7, number 34. A fence 8 feet tall runs parallel to a tall building at a distance of 4 feet from the building. What is the length, the shortest ladder that will reach from the ground over the fence to the wall? So you have an 8-foot fence. You have a very tall building, which we'll call Y.
Okay.
You know it's 4 feet here. And you're going to have a ladder some distance, which I'm going to call X, away. And it's going to go right there. So you have two similar triangles. And they want you to optimize, I'm going to call it D for distance, but that is the ladder length D.
Yes.
All right, first thing I know is I can write a ratio here. Y over 4 is equal to 8 over X. I know that ratio is true for my relationship here. But what do I want?
Don't you have to go 1 plus X?
No, you don't have to. You can do it over the legs. Remember, we learned in geometry that you can just do the parts?
No,
Okay.
I don't think.
Okay. So you can do the parts, all right? But I guess, hang on, if you want to do it that way,
Let's do it that way.
because that's probably what you would remember, so we'll do it that way. X plus 4.
Okay.
So now, if we go, what's the relationship between D, Y, and X plus 4?
You can go D squared.
You can go D squared
Plus 4
equals
plus X.
Y squared plus X plus 4,
Plus
quantity squared. You guys all agree?
Yes.
When we optimize, there is no time here, right? It's not like the ladder is being
You're
run
gonna
up a
set it
wall.
to 0. So you
Well, before you can even do that, how many variables do you have to have?
1.
1. And if we're going to minimize the height of the ladder, do we agree that we're going to minimize the square of the ladder? So I don't have to do the square, right? I can say D equals this. We can do that little trick.
Y equals this.
All right, exactly. If you cross multiply, I'm with Cody. If you cross multiply,
This is supposed to be an X.
I'm going to make it a lot easier.
Y equals 8X plus 32 over X.
Yeah, how about this? Y equals 8 plus 32 over X. How about we do this instead?
You know what? I'm not really that sure.
Okay? It's going to make our life a lot easier to deal with 2 terms, I think, than 1. All right, so here we go. I will substitute that for Y. And now I'm optimizing.
Is it a Y?
All right, now I'm
Can I set it
optimizing.
to 0? Joey?
Well, before I can set it to 0, what do I have to do first?
Where's the derivative?
I got to take the derivative of this. Which, guys,
This is wicked.
no, chain rule this thing. Chain rule this one.
Yeah.
Do not multiply this
I don't
out.
like chain rule.
2 times.
It's easy.
It's just so much writing.
Derivative of 32 over X is negative 32 over X squared. Plus, derivative of this is 2 times X plus 4, derivative of the inside is 1. There is no way that that's not faster. All
I
right?
just don't like it.
You might not
What?
like it. I just did the chain rule. I just did the derivative as a chain rule. It's 2 lines. Derivative of this term is, bringing 2 down, 2 times this. Derivative of the inside is, all right, is that. I will distribute all this stuff.
Would this be a calculator problem?
This would probably be a calculator problem, because I might not even distribute this. Can I use solver right now on your calculator to solve this? We have to set this to 0. We want to know what value of X we get. So 0 equals to all this stuff. So we can put this in solver.
Dang it, that was all squared. Are you just handing it out? There, sorry, excuse me. Or possibly here. Yeah, I'm not doing this really well this much.
All right, I get this. And you can enter this in your calculator. You guys agree?
We need to get faster with these problems.
Yes, you do. That's why we're practicing. And again, that's why you can, I'll put these up, you can watch these videos again, all right, and see if you can't work through the logic. The best way to practice is on problems you know the solutions to, all
No, it's
right?
not, because then I know the answer and then it doesn't help me.
Only if you can say why each step happened, all right? And the biggest step,
I just
most of the time you're
remember-
missing
I
is
just remember
taking,
the numbers though, like I wish we had a problem every time.
all right. If I do this, this is a really big ugly problem, all right? And you definitely need to use your calculator. And you can use solver on your TI calculator under math, right?
Yeah, and it's like one in the bottom, so.
I gotta believe the ladder
Right.
X is gonna be fairly close.
Nope, that's pretty much approved.
I'm gonna guess that X is gonna be fairly close to like 5 or 6 feet if I had to guess.
I only did the ones that weren't approved.
Alright,
6.3496.
6.3496. I'll buy that. Especially since your calculator told you that. Alright, and that's from Solver. It'd be really hard to solve this without a calculator. Just to do the work for you. Alright? It's a quad because it's gonna end up being a cubic. No, it's gonna end up being a fourth order.
But we found X.
Alright, so isn't that how far away it's gonna be from the fence?
Yeah.
Isn't that what the question asked for, or did it ask from the building?
I thought it was how long does the,
Oh, so how long does the ladder be? Alright, so now we have X.
so then
So,
we have to find Y and then
If
we have to
I,
find D.
alright, well, if I'm gonna find the ladder length, do you guys agree? I can
Well,
take,
now I can't use the ratio?
can't we use, well, oh, we can use the ratio to find Y, or couldn't we just use this equation? We know D squared, the length of the ladder squared is all this. Right?
Okay.
That's our original equation before the derivative. So if I copy this, it'll let me.
You have band today?
Yes.
Oh.
Alright, if I copy this, and I paste it, and I bring it down, then again, this is not, this would be the length of the ladder squared. We can substitute X into this equation, right? And whatever the square root
It's
is,
a very long ladder.
well, it's gonna be a long ladder, because you've gotta cross an 8-foot fence and then get to the building. It's gotta be a very tall ladder, it's gotta be 50 feet.
Sure. I got 277.1476 feet. And then I have to discover that. 16.
16.6478.
Joey, what's number 16? What kind of quad is that?
16.64.
It's a diamond, but
Is it equilateral?
So I have a question on the AP.
Lateral
Would they probably give you like
Is it like-
16,
oh,
they
it's
give you
like
that
equal.
answer, then they'd probably give you like
you have to decide what
16.5
type of quad
something?
or lateral.
What are the choices?
Well, for a multiple choice?
Yeah.
No,
You
they
just have to
give you a
know.
4-place decimal if that's what it
I don't know what
was.
kind of quad
Most
you're
likely on the AP, if it's a calculator section, it would work out to something ugly. If it's on a non-calculator section, it would work out to an integer. They would make it a Pythagorean triple, right?
That's a
A
quad.
5, 12, 13, a 3, 4, 5, 6, 8, 10,
You
you know, something like that.
Right.
All four sides are.
All right,
Yeah.
again, this is
I think it's
optimization. The
square.
big difference is it's not based on time.
Yeah.